in a bit of a period time machine here.
In the age of the machine, every decade is defined by its engineering masterpieces. So join me on a journey through time as I experience the great machines that changed people's lives and shaped modern Britain. I'm in a decade that began with great advances in the quality of people's lives, yet ended in World War II. A decade where 2 million cars suddenly appeared on our roads. Streamlining was the watchword in technology, and speed records held the public fascination. Welcome to the 1930s.
A decade whose mass production and speed technologies left Britain better prepared than many think, but on the road to war. I'm at Britain's main international airport, Croydon. What? I hear you say, Croydon? It doesn't even have an airport. Aha, it did.
And in the 1930s, this stunning building was Britain's gateway to the world, the Heathrow of its day. The place that Amy Johnson took off from on the 5th of May 1930 for her record-breaking flight to Australia. And the base for Britain's major airlines, all competing with one another for the growing market in air travel.
This is what remains of the old ticket hall. Down either side were check-in desks. Over there, Royal Dutch Airlines, now KLM. And just over there, Britain's Imperial Airways.
In the 1930s, the check-in experience was somewhat different to today's, though. You couldn't check in your standard 20 kilos of luggage for a start. It was nearer half that. And it wasn't just the luggage that was weighed, it was the passengers too. Those that failed the weight test had to sit slap in the middle of the aircraft, or once airborne, it would tip up.
Let's hope the extra sausage this morning hasn't pushed me over the edge, eh?
One would hope so, sir.
Like the check-in experience, the aircraft of the day were very different too. Some were antiquated machines with open cockpits, others airliners in the very real sense. More like cruise ships of the sky.
I've been allocated a seat in the tail, but what sort of strange machine will I be flying in?
This is it. The de Havilland DH-89 Dragon Rapide. This great machine was one of the world's first completely streamlined airliners. She operated as a short-haul specialist, speeding passengers all over Britain and Europe. So before I embark on a flight of my own, let's see what made her tick.
What an absolute beauty. You can almost smell the 1930s coming off her. Aesthetically pleasing from any angle. Powered by 2 Gypsy Queen engines, inline 6-cylinder air-cooled, each knocking out 200 horsepower.
Pretty powerful by car standards, but not much as today's airliners go. Even the smallest modern jet knocks out about 5 times that.
To help the engines get the aircraft off the ground and carry its payload of 8 passengers, the Rapide has 2 14-metre wings rather than just the one we're used to nowadays, and that gives it loads of lift.
It might not look very advanced, but it was for the time, incorporating the latest watchword in 1930s technology: streamlining. The whole of the exterior has a flowing, slippery shape right down to the trousered undercarriage, reducing air resistance and maximizing its speed and range. With this slippery streamlining, the Dragon Rapide was good for 578 miles at 132 miles an hour. More than enough for its first operators, Hillman Airways, and their short-haul routes from southern England to Scotland, Ireland and France.
Hillman were one of the world's first budget airlines, with the revolutionary idea of making air travel just like bus travel. But with the cost of a ticket, a one-way ticket to Paris at just over £4, £350 in today's money, it was still a bit expensive for the average man. Let's have a look and see what you got for your money.
There's only 8 seats. and not a lot of luxury. But that's not the point. What made this machine great was the fact it could get you from the centre of London to the centre of Paris in just 3 hours and 40 minutes.
The engine's just chugging along nicely. They sound very smooth, very strong at the moment. Let's hope that remains the case.
For years, I've had a fear of flying, so...
Why are you going up in a 1930s airliner then, one would ask? Hey, you only live once. We are now, I would say, preparing for a takeoff roll. You can hear the sound of the engines now as they rev right up, and this is a takeoff roll. Up we go, and this, you can feel the tail wheel lift now as we come along to the horizontal. It is a little bit blustery there as we feel, but the big biplane now is in the sky. A very short little takeoff run there, and we are in the skies. Absolutely magnificent. You can hear the smooth 2 Gypsy Queen engines dragging us up, and we seem to be airborne with very little effort. There weren't any stewardesses on this aircraft because there simply wasn't any room. So I'll show you the emergency exit myself. And here it is. It's simply a hole in the roof. What you did was you pulled this here, pull emergency use only. There's a little blade in there, and it cut a hole in the roof, and out you went. What you did when you got there, I don't know, but there it is. There were no in-flight announcements from the pilot because there was no intercom. Instead, and I love this, every now and then a hand would appear from the cockpit with a note. Oh, here's one now. We're over Dover, pass it back. The pilot. It works.
So, the passenger experience was fairly basic, but what was it like for the pilot?
Hi, Barry.
Hi, Chris.
How's she handling today, Will?
It's very well. Quite good flying conditions today, so it's relatively smooth, as you can feel for yourself.
Visibility here is fantastic, isn't it?
It's panoramic all the way around the cockpits.
Yeah.
The first glass cockpit that you never heard of.
That all-round panoramic view really came into its own for landing. The aircraft's curved, streamlined wingtips help it go faster, but they also mean it has a tendency to tip stall or swing round on landing, meaning this is very much a machine the pilot's got to fly all the way to touchdown.
Well, we're coming into land now. Absolutely superb flight. Quite a steep descent there, and before we know where we are, we're touching down. Oh, bit of a one there, bit of a one, and we're down. We are down. We are down, and that was a remarkably smooth landing. We're a tail dragger, of course, and there you can just feel the tail bouncing down. Really, really impressed am I with this aircraft.
Throughout the 30s, the Dragon Rapide carried passengers all over Britain and Europe. But not all airliners of the period were quite what they seemed. Many were used to test new bomber technologies, or in the case of the German carrier Deutsche Lufthansa, for spying runs over British airfields. When war broke out, the Dragon Rapide would be called up in large numbers, its wooden structure making it quick and easy to build, and it would serve largely as a navigation trainer. But for a few happy years in the 30s, Britain's great short-haul airliner simply played its part in changing the way people travelled. Changes that weren't just limited to air travel. In the 1930s, new mass production techniques imported from America were being harnessed by British factories for all manner of labour-saving goods, from teasmaids to vacuum cleaners, making them affordable for ordinary people and transforming their lives. British car manufacturers like Morris Motors adopted mass production too, with the result that more and more people could afford to own a car. By the end of the decade, there were 2 million vehicles on the road.
Great, but at the beginning of the 30s, there was one small problem. There were very few proper roads to drive cars on.
Happily, or rather unhappily, the beginning of the 30s also coincided with the peak of the Great Depression.
Millions of people were unemployed, so the government came up with a plan to kill two birds with one stone. A massive road building programme.
Thousands of miles were built during the 30s, with the new Liverpool to Manchester road alone employing 809 people and 220 construction lorries. Construction lorries like this, a 1934 Sentinel steam wagon. Yes, a steam wagon. Believe it or not, they were still building them in the 30s. It might seem antiquated, but this really was a great British machine. Boiler pressures of 255 pounds per square inch, the same or even more than a steam loco, meant these steam wagons generated 5 times as much power as the petrol lorries of the day, making them very much the workhorses of choice for the construction industry.
Driving a steam wagon is a tad different to driving a car. For a start, you've got a baking hot fire in the cab with you, heating the water to a staggering 165 degrees Celsius. A fire you've got to keep going by shoveling coal into the boiler here via the stoke chute at the top. Now, given that steering and shoveling coal is a bit tricky to do at the same time, steam wagons were most definitely a two-man operation.
This is my stoker, Jim Sarney.
When these wagons were used commercially, they covered hundreds of miles, even hundreds of miles in a day sometimes, and a fireman was essential. So basically the fireman, his job is to stoke the boiler and keep pressure up. That's his main job.
It might seem a bit primitive, but believe me, these things go like stink.
So, Jim, this wagon will be good for 50 mile an hour?
Oh yeah, yeah. When these wagons were built, there was nothing to touch them. Nothing to touch them for speed, nothing to touch them for power.
These massive haulage machines don't just run on coal. They need water too to make their steam, and can only carry enough for 30 miles. So, what did the steam wagons do when they needed to fill up? They couldn't just pull up at a petrol station. No, it was much more fun than that. They simply kept an eye out for ponds and streams as they went along, and if they couldn't see any of those, simply borrowed it from whatever they could find. Fire hydrants, or even animal troughs.
So here we are. A horse trough full of water. Now to deploy the steam wagon's water borrowing device. And here it is, essentially a hose with a filter on the end to keep out sticks and fish and the like. Now, using the wagon's steam power, the hose essentially sucks up the water into the tank. Take it away, Jim.
A 1,054 water-sucking, smoke-belching Sentinels were made in the 30s, with some adapted for all manner of roles, including road building.
Well, flatbeds like this one would have simply carried the construction materials to the site. But there were other much more specialised Sentinels out there.
Like this wonderful Sentinel concrete mixer. A lot of 1930s roads were made of concrete, with the concrete poured into vast wooden frames.
Frames like this, only bigger, where the concrete was smoothed over and left to set.
On some 1930s sites, there would have been hundreds of these concrete squares, all joined one to another.
Once the concrete had set, they pretty much had their road. However, concrete on its own is fairly slippy. So to help the cars get some grip, they often added one more ingredient.
Tarred chippings. And that's where the specialist Sentinels really came into their own. They made perfect tar transporters, as the heat from their steam boilers could be used to keep the tar melted.
So with your skid-proof surface applied, that was more or less it. One new 1930s road. Simple as that.
With a decent road network in place, the 1930s motorist could finally tour the country with ease in one of the popular cars of the time, like this wonderful Morris 8. A small car, but a great one, because thanks to its cheap price and vast numbers produced, it brought car ownership to the masses, freeing them for the first time from the tyranny of bus routes and timetables. But that freedom came at a cost, as these new roads and cheap cars came with new traffic regulations. Costing the princely sum of 37 pence, 1935 saw the introduction of the compulsory driving test.
There were no test centres as such. You just picked up your examiner at a pre-arranged spot by the side of the road, which is exactly what I'm going to do now. Wish me luck.
This is my driving examiner, Alan Spillman. He's a Morris 8 man through and through.
Alan, so, back in 1935, that first driving test, what sort of things would have been in the test?
Well, first of all, there was the highway code, as per now, but the questions were a little bit different.
OK. Try me.
What is the correct way to overtake a tram?
Subject to local provisions to the contrary, a tram car may be overtaken on either side.
Correct. What must you not do to a traffic constable?
Never, if it can be avoided, put questions to a constable regulating traffic. This may distract him, causing obstruction or danger.
Brilliant.
OK, now for the practical test. One of the main things was arm signals. A lot of cars didn't have any indicators, so there were loads of arm signals in the test, starting with turning left.
Now, you may be wondering, how on earth do you do that? Do you have to lean across your passenger and stick your arm out of the other window? No, you don't. And I do know this one because it bears a resemblance to a certain salute I have to perform every now and then. And I'm indicating left now.
Should have packed that spare arm, shouldn't you?
You were kept busy back in the day, weren't you?
Next came reversing round a corner. Not as easy as you might think in these non-synchromesh cars. And finally, the emergency stop. A very different operation compared with today, using 1930s brakes.
And stop.
How was that?
Thank you.
63% of drivers taking the new test passed, many of them in Morris 8s. Mass production techniques pioneered by Morris's factory guru Leonard Lord meant the cars were plentiful and cheap. But the advantages of mass production didn't stop there.
The economies of scale meant that cars were becoming cheaper. These huge concerns were able to tool up and offer extras on cars that would have been unthinkable 5 or 6 years before.
And in terms of mass production, did that help in the maintenance of these cars?
These cars are remarkably easy to work on for the DIYer.
Well, I have to say, as I've been driving this car today, I've just enjoyed it more and more and more. It really is excellent. Everywhere you look, you see a nice little feature or a nice line. I love the steering wheel, you know, it's beautiful. I love it, I really do.
The only things that weren't great in their day were the lights. But even then, you could still see where the road went, thanks to an ingenious piece of 1930s invention. Cat's eyes. Rumour has it their inventor, Percy Shaw, was driving home one dark night in 1933 when his headlamps were reflected by a pair of cat's eyes. In a eureka moment, he decided to try and copy them and use them to mark unlit roads at night. So how did he do that?
Like all the best ideas, incredibly simply. He just got 4 small glass reflectors, embedded them in a block of rubber, 2 at either end, and attached it to the road via a metal plate. Very much the same as this.
When a car shines its headlights at it, the light is reflected back, marking the line of the road. And if a car drove over it, the reflectors simply got squashed down into the soft rubber base and didn't break.
And here's the really clever bit. If the rubber block was wet from the rain, it would actually wipe the cat's eyes clean before they pop back out again. Brilliant.
One of those little British inventions that took the world by storm and has stood the test of time. Today, there are 20 million of them on Britain's roads. But in the 1930s, the road builders and car manufacturers weren't having it all their own way. 20,000 miles of rails crisscrossed the country, with 4 major train companies offering something the crowded roads couldn't: speed. Fastest of all was the London and North Eastern Railway, operating the route from London to Edinburgh. Their trains, including the famous Flying Scotsman, could cover the distance in 7 hours 20 minutes. That's much faster than the average 1930s car, and with considerably more comfort as well. You can even have a haircut. The driving force behind the LNER's speed was their chief designer, Sir Nigel Gresley. Gresley's great skill was to track down the best train technologies in the world and apply it to his own machines. To this end, the early 1930s found him in Germany, travelling on the Fliegende Hamburger, the fastest train in the world at the time. The Fliegende harnessed the new science of streamlining, and Gresley decided to apply the same technology to the LNER locomotives back in Britain. Streamlining centres on making the airflow over a given machine as smooth as possible, minimising wind resistance, maximising speed. Great in theory, difficult to work out in practice, as you can't actually see the air flowing over a given machine. Or you couldn't until wind tunnels came along. Britain's main wind tunnel was built at the National Physics Laboratory in Teddington, London, and that's where Gresley headed next. In a wind tunnel, air is blasted over a machine like this. And then smoke or some other indicator is added to see how the air is flowing and generally behaving. Using the wind tunnel, Gresley calculated that by adding streamlined plates to his prototype, like this, his locomotive would need 40% less power to overcome air resistance and could reach a much higher top speed. That model became this, the Gresley A4 Pacific. For my money, the greatest steam locomotive ever built. As you can see, every surface of this enormous machine is smooth and curved, minimizing drag and maximizing speed. The driver, Stuart Nellams, and his firemen have been here since before dawn, heating the boiler and creating enough steam pressure for us to run. Steam pressure is round about the 250 pounds per square inch mark. We need a minimum of 150, so we're well ready for the off. The enormous steam-belching engine feels like it's alive. And now I'm going to get to drive it. My greatest loco of all time.
You can take the brake off, moving towards the window.
And I'm looking at the brake.
Look at the gauge.
Oh, yep, there we go.
Down to zero,
Right,
that's it, lovely. And then onto the really important handle, which is the regulator. Now that lets the steam into the boiler.
We're rolling a little bit anyway,
yeah,
but...
she's on a little bit of a gradient. If you ease that open...
Oh,
there she goes. Pause like that a second. OK, and you can just feel her take off. There's an awful lot of power on the end of that handle.
And then, exactly, a lot of power on the end of that handle.
That's right, exactly.
And then you put it back to where it was.
Basically, we're letting 50 pounds of steam into the cylinders.
Right.
Out of a potential 250.
OK.
Now we've got going a little bit, you can now alter the reverser a bit.
OK.
To make better use of the steam.
Right.
So go back up to sort of 45, something like that.
OK.
Off we go to Edinburgh.
But you can feel the power as soon as you open the regulator and get moving.
That's right, there's an awful amount of power there.
Power on the end of the handle is very evident. It really is. Okay.
We're just rolling now, so we just let a little bit of momentum go.
So that's just the momentum we're rolling on now. Incredible.
Yeah.
Incredible.
Trains do just as much rolling as they ever do with power on.
Yeah.
And the more weight you add, the quicker they'll go.
Oh, yes. But no matter how fast and powerful a locomotive is, it doesn't make a train. So before we go any further, we've got to pick up 6 or 7 carriages in that siding over there. I've driven an A4. That's fantastic. That is fantastic, and the sense of power is greater than anything I've ever driven before.
Gresley's ultra-streamlined A4 began service on the 1st of October 1935. It was an instant success, smashing the journey time from London to Newcastle to just 4 hours. But that success was very nearly a failure.
Gresley's streamlining made the locomotive incredibly fast and efficient, but the prototype had one major drawback.
A drawback that meant you might get to Newcastle very fast, but you'd resemble a smoked kipper by the time you got there.
It wasn't just air that flowed beautifully and smoothly over the surface of the engine.
Smoke from the chimney did too, carried along the surface of the loco and onto the footplate and into the carriages. Definitely not good for comfortable travel, but solved by a piece of luck in the wind tunnel.
During testing, someone managed to leave a thumbprint on the model by mistake, right here behind the chimney. But as luck would have it, once they fired up the wind tunnel, they found that the thumbprint actually solved the smoke problem.
The indentation caused by the tester's thumb interfered with the streamlining just enough to let the smoke escape from the surface of the engine. So that thumb hole became part of the real locomotive being cast into the full-size chimney.
But the thumbprint wasn't the only clever part of the A4's chimney. It also has a device called a Kyle-Chap double blast pipe, which improves the drafting of the fire, which makes the A4 go even faster.
The Kyle-Chap's extra speed was to prove vital when, on the 3rd of July 1938, the latest A4, the Mallard, set off on an attempt to break the world's steam speed record. If Gresley and the LNER could capture it, they'd gain a fantastic marketing tool against their competitors. At the top of a hill called Stoke Bank, Mallard started her record attempt.
Everything now depended on fireman Thomas Bray, the rate at which he could shovel coal into the firebox and how hot he could keep it.
A mile downhill from the summit, Mallard was doing 87.5 miles an hour, then mile by mile 96.5, 104, 107, 111.5, 116, 119, 122.5, 124.25, then 125. For a brief moment, it hit a staggering 126 miles per hour.
Mallard had taken the world steam speed record, which stood at 124.5 miles an hour, and was held by the Germans.
Gresley's streamlined masterpiece still holds the record to this day, making it, for my money, the greatest steam loco in the world. Unfortunately, it would need a lot more than a fast train to take on the might of industrial Germany on a battlefield. And as the 30s wore on, it became increasingly evident that that was exactly what Britain would have to do. 1933 had seen Adolf Hitler come to power in Germany, and as he became ever more aggressive towards the countries around him, Britain began a massive rearmament program, centered on the same mass production factories that had improved people's peaceful lives at the start of the decade. Factories that could put 2 million cars on the road could also produce weapons in vast quantities. Morris Motors specialized in tanks, very fast tanks.
The tank had first appeared 20 years earlier in the First World War with 28-ton monsters like this, Willie Mark I.
At 4 miles an hour, these tanks were incredibly slow. and mostly used to support soldiers on foot as they hammered away at the enemy's front line. However, during the 1920s, Britain's experimental mechanized force came up with a different way of using tanks.
Their idea was for old heavy tanks to punch a hole in the enemy's front line, and then for new fast tanks to race through that hole, drive deep into enemy territory and attack headquarters and lines of communication.
The British military adopted the new ideas and in 1936 asked Morris to build them a very fast tank to carry them out.
And this is it, the Cruiser 3, 15 tons, 2-pounder gun, crew of 4, and good for 30 miles an hour off-road, making it one of the fastest tanks of its day.
But what made this great machine so fast? The answer lay in one man. American J. Walter Christie and his genius for high-speed tank design. Morris bought one of Christie's tanks and harnessed the revolutionary ideas they found in it. Firstly, huge wheels, much bigger than on other tanks, coupled with massive horizontal suspension hidden behind the armor plating. With these two things, you could go flat out on rough ground, at 30 miles an hour, much faster than most other tanks of the day.
Christie's other big speed idea was simple too. Don't just put a giant engine in your tank, put in an engine with the best power-to-weight ratio you can get your hands on. What machines use light engines with lots of power? Aircraft. So for maximum speed, use an aircraft engine in your tank. And listening to Christie, that's exactly what Morris did.
Building this beautiful V12 340 horsepower Nuffield Liberty aircraft engine for their Cruiser 3 tanks.
Wouldn't it be amazing to hear this motor running? Well, believe it or not, we can, in the next fast tank that Morris built.
The Crusader. It was on the drawing board in 1939, and like the Cruiser 3, it's got Christie's huge wheels and that enormous, all-powerful Liberty aircraft engine.
One of just a handful of Liberty engines left in the world that still run.
This tank and its engine are literally priceless.
Turn it over, Colin.
So, to help me start it and make sure I don't do any damage, I've got two experts on the engine to help me.
Again?
John Pearson and his son Colin. Health and safety wasn't exactly central to 1930s designs. Those valve rockers will have your fingers off.
Absolutely brilliant. Oh, well, John, what a sound. Beautiful sound, isn't it?
That engine is so loud, more like a dragster than a tank. And it made the Crusader at over 30 miles an hour off-road one of the fastest tanks on the battlefield.
Had that 30-mile-an-hour speed to sort of get out of trouble.
Yes, it was a very difficult target to hit when it was running, and in fact that was intended to be its defence, was really to keep out of the way.
So, the Crusader was one of the fastest tanks around. But did that make it the greatest? Unfortunately not, as it was dangerously unreliable.
Crusader was agile, it was fast, but it was very fragile, and it would break down quite regularly.
So I suppose when it was broken down, obviously it was a sitting duck.
Yes, that's right, it'd just be an immobile and not very thickly armoured pillbox.
Which was a worry, because whilst Morris in Britain were building their tanks, another motor manufacturer was secretly building tanks too. Daimler-Benz in Germany. This rather sinister machine was one of them, the Panzer III. Secretly working on them since 1934, These were the very tanks the Germans used to invade Poland in September 1939, the invasion that started World War II.
Well, it has to be said, this Panzer III sounds and feels much more like a luxury limousine compared to the Crusader.
In 1939, the Germans smashed through the Polish front line, then raced on, attacking headquarters and lines of communication, mirroring the tactics pioneered by Britain's experimental mechanized force all those years before, and which the Crusader had been designed to exploit.
So if we look at a Crusader versus a Panzer III, how do they compare?
Well, they're surprisingly similar. They were built very much the same sort of type, similar type of engine, although the engine in the Panzer III is only about half the size. The big difference, I suppose, is the suspension.
The Panzers lacked the giant wheels and suspension of the British Crusader, meaning the Crusader was much faster off-road. But its amazing Christie suspension gave the Crusader another advantage too.
The Crusader, the crews were expected to shoot on the move because of the good suspension, whereas a German tank would normally come to a halt before it fired.
So contrary to popular belief, the Panzers were a long way from perfect. If only the ingenious, high-speed, fire-on-the-move Crusader had been more reliable, it might have been one of the greatest of its day. Thankfully, Britain's fastest weapon of all was the greatest of its day. A state-of-the-art war machine built right on the edge of known technology. And it would go on to save the nation during the Battle of Britain. The Spitfire, a national treasure that had had its origins right back at the start of the decade, in a little racing float plane. That little racing float plane was a world record breaker, the Supermarine S6B, designed by aerodynamic genius R.J. Mitchell to compete for the 1931 Schneider Trophy.
The Schneider Trophy was an international race for seaplanes. Tiny aircraft which at the time were quite literally the fastest speed machines on the planet.
They were also amongst the most life-threatening, with an atrociously high death rate, thanks to the aircraft being built right on the edge of known technology. This one's at Southampton's Solent Sky Museum, and if you thought the Gresley locomotive and Dragon Rapide airliner were streamlined, you ain't seen nothing yet.
The extreme streamlining is stunning, bordering on the terrifying. The float struts and the wings are really thin like knives, reducing drag. And the cockpit windscreen is tiny for the same reason.
It's a cockpit built for death or glory.
Turn that way.
There's not even a seat. The pilot had to squeeze himself in and sit on the floor.
My shoulders are kind of stuck in here at the moment. Of course, straight ahead of me, I can't see anything but the huge, huge engine.
An utterly insane 2,350 horsepower Rolls-Royce R-Type, which was almost impossible to stop from overheating. On its first run, it only lasted 15 minutes before disintegrating. And even when fully developed, only had a lifespan of 5 hours. On the 13th of September 1931, the S6B and its mad engine left its hangar on Calshot Spit near Southampton. My model is following in its exact footsteps.
That's it over there, practically unchanged after all these years. As Boothman, the pilot, accelerated, just like my model.
His seaplane lurched into the air. Earlier, one of the British team's pilots had crashed and been killed during practice, decapitated by his own cockpit. But Boothman was determined to race for glory.
The 1931 race took place here on the Solent on a 50-kilometre course, taking in the Isle of Wight, West Wittering, Gosport, and then on to Leap.
Watched by a crowd of nearly 250,000 people, Boothman completed the first lap at an average speed of 343.1 miles an hour, a new Schneider record.
It would take this boat roughly just under the hour to complete the course. Mitchell's F6B could fly it in 5.5 minutes.
The tiny windscreen made it very difficult for him to see the course. And on the 6th lap, Boothman just missed Ryde Pier. On the 7th, he dived for the finishing line, and as steamers around the course sounded their sirens, captured the Schneider Trophy for Britain. 16 days later, the tiny aircraft took to the skies again, this time setting a new world speed record of 407.5 miles an hour.
It was the first time man had ever been over 400 miles an hour, and lessons learned in its design would go on to save the nation during the dark days of war, in the Battle of Britain.
The Battle of Britain, fought in 1940 in the skies over southern England, saw 900 British fighters desperately driving back the 4,000 aircraft of the attacking Luftwaffe. The most famous of those British aircraft was the Spitfire, designed, like the S-6B, by Supermarine's speed expert, R.J. Mitchell.
Luckily for Britain, Mitchell's Spitfire was an ultra-fast, state-of-the-art speed machine, just like the S-6B. But unlike the S-6B, of which only 2 were built, the Spitfire was built in vast, vast quantities. By the end of the war, 22,000.
To really understand the Spitfire and how Mitchell drew on his experience with record-breaking seaplanes to create it, we really need to meet it in the raw, get under its skin as it's being built.
But the last Spitfire rolled off the production line 62 years ago, so that's impossible.
Or is it? Look at this.
This is the Aircraft Restoration and Historic Flying Company based at Duxford, the same place as the first Spitfire squadron. It looks like a modern Spitfire production line, but these machines are all World War II originals and are here to be rebuilt.
This is absolutely amazing. It's like going through a time warp into 1939. Over here we have a Spitfire wing in bare aluminium on a jig about to be worked on.
There's even an original Mark I Spitfire in here, one of the first to see action. It was shot down over Calais and fished out of the sea. And just like on Mitchell's revolutionary seaplanes, everything is made of metal. Tiny, light aluminium frames covered with high-speed metal skins that actually give the Spitfire a lot of its strength. Most other aircraft of the time were simply made of heavy wooden frames covered with canvas. Those thin wings with their strange elliptical shapes were also absolutely definitive of the Spitfire. Ultra-thin wings were a speed trick Mitchell had perfected in his Schneider racers. But why the strange shape? Well, the Air Ministry, who were funding Mitchell's prototype, wanted a fighter that could climb very fast to intercept enemy aircraft, but also carry machine guns to shoot them down with, up to 8 of them. Mitchell and his team worked out by making the wings elliptical, they could reduce the wing's thickness and drag to a minimum, yet still have lots of strength, and room inside for retractable undercarriage and all those machine guns.
Making the Spitfire very speedy and packing a massive punch.
That strange elliptical shape also worked hand in glove with something else that gave the Spitfire speed. Its heavy new engine. An engine that's become a legend. The Rolls-Royce Merlin. Just like the Rolls-Royce R-Type that had powered Mitchell's seaplane, it's a massively powerful V12 with supercharger technology.
But unlike the crazy R-Type, it could run for a lot longer than just a few hours before potentially blowing up. It still needed a lot of cooling, though.
Mitchell had solved the mad R-Type's cooling problem in the Schneider racer by literally turning the whole aircraft into a flying radiator.
A staggering 50% of the aircraft, the entire upper and lower surfaces of the wings, even the floats, had hot water from the engine pumped through them to be cooled by air howling over the aircraft as it sped along. It was enough to keep the R-Type from disintegrating in the little racer. But Mitchell couldn't cover half of a fighter aircraft with radiators, as they'd be far too vulnerable to bullets.
So, he pumped the hot engine water through these scoops hidden under the wings instead. Air rushes into the scoops, cooling the engine's water, then exits out of the back.
But here's the really clever bit. Because the air is squeezed in the scoop, it comes out of the back faster than it goes in the front, acting a bit like a ramjet, blasting the Spitfire along, giving it even more speed.
Mitchell's prototype Spitfire rolled out for its first flight on the 5th of March 1936.
Well, it truly is a thing of beauty. It looks fast, even though it's just standing still. And of course, it was fast. The original Mark I did 350 miles an hour.
The Air Ministry were delighted by the Spitfire's performance and ordered 310 on the 3rd of June.
Oh, listen to that, absolutely superb. Bit of smoke, a few flames, and then settling down into that fantastic even beat. Nothing could be better.
They said I could have a ride, but this wasn't exactly what I had in mind. Human ballast to counter strong tailwinds on a beautifully restored machine's taxiing run. But still, an amazing experience. Tragically, Mitchell died in 1937 and never saw his masterpiece go into service. But thanks to his engineering genius, when World War II started, Britain had a truly world-beating aircraft with which to defend herself. As the 30s came to a close, there were tough times ahead. But thanks to the great changes in mass production, transport and speed technologies which the decade had brought, Britain was much better prepared than she might have been on the road to war.